Okay, good afternoon, everyone. We will start with the first presentation of the second session in CompleNet. Moniba Keymanesh will start her speaking. Please write your questions, and I will start to count your 15 minutes, Moniba, and I will tell you when you have 5 and 1 minute left.
Okay, so shall I start now?
Yeah, please.
Okay. Hello, everyone. This is Moniba Keymanesh, and today I will present our work called Twitter Watch, Leveraging Social Media to Monitor and Predict Collective Efficacy of Neighborhoods. This work was supported by National Institute of Health. This is the crime map of Columbus, Ohio during August 2018. And as you can see on the map, crime happens with different rates in different areas of the city. Sociologists often associate this spatial variation of crime with a concept called collective efficacy, which is defined as mutual trust among neighbors and collective willingness to intervene for the common good. Collective efficacy is usually measured by conducting survey studies that ask individuals to answer questions about their perception of their community and safety of their neighborhood. And collective efficacy is important for local governments to understand which neighborhoods have a more of an internal mechanism to control crime and to prioritize resources to monitor and reduce disorder by targeted policies. However, there are limitations with the traditional survey studies. These surveys are extremely costly to conduct, and they're conducted very infrequently, usually just like once in a decade. And policy shifts and gentrification efforts changes the level of collective efficacy in neighborhoods. And therefore, in order to access the current level of collective efficacy, these studies need to be done more frequently. So in this study, we wanted to know if we can leverage social media data about neighborhood to predict their collective efficacy level. This enables us to access the collective efficacy values more frequently and in a much lesser cost. To investigate further, we collected data from two sources of data. The first source of our data was the Adolescent Health and Development in Context study, which is a study conducted at The Ohio State University. We asked 1,400 residents to respond to survey questions that asked users to answer questions about how safe they feel in their neighborhood. We ask users to tell us if they trust people in their neighborhood, if they feel other people are watching what's happening in the neighborhood, and if they expect someone to come and help them if they're in trouble. We aggregated, users responded to these questions on a scale, and then we aggregated them to the neighborhood level to build the ground truth of our study. This is the collective efficacy map of Columbus, Ohio. And as you can see in this figure, the neighborhoods that have like a more purple shade, they have a higher level of collective efficacy. And neighborhoods with more of a red shade, they have a lower level of collective efficacy. To match with our offline data, we also collected a significant amount of tweets from Columbus residents. To start with, we targeted 63 seed Twitter accounts that mostly tweet about events or organizations in Columbus, Ohio, including local universities, sport teams, restaurants, and so on. Using snowball sampling, we collected the Twitter accounts that followed these accounts and also mentioned in their Twitter bio that they're from Columbus or one of the suburbs. At the end of the step, we collected around 50 million tweets. But what we were really interested in was the informal language of local residents that were targeting local venues and localities. So we used a location name extraction method called Linux to extract location names and mentions from tweets. And we only focused on the tweets that were actually talking about a location. Obviously, there are some mentions, location mentions, that are not mappable to a neighborhood. For example, if a user is talking about their visit to a McDonald's, we cannot really know what McDonald's they're talking about. So we only excluded these ambiguous mentions from our data, and we worked at the end with 540K tweets that were mentioning 4,800 locations in 484 census block groups in Columbus, Ohio. So sociologists and government agencies usually use collective efficacy to order neighborhoods based on their safety. So one might essentially solve this as a ranking problem. More concretely, we ask the following question. Given the social media data about neighborhoods, can we predict the ranking of neighborhoods based on collective efficacy? We solved this ranking problem using a pairwise learning to rank model, which has two main modules. The first module, given the tweets associated with a pair of neighborhoods A and B, extract different spatial and linguistics features from the content of the tweets, and then build a feature vector for a pair of neighborhoods. This feature vector will be the input to a local ranker, which is essentially a classifier that predicts the local order of the neighborhoods in terms of collective efficacy. So in this classification task, one neighborhood can be higher than the other one in the ranking, can be tied with it, or can be lower. As I mentioned before, we extract several linguistics features from the content of the tweets. And these features are proxies for different predictors of collective efficacy, as mentioned in the sociology literature. One well-known theory in criminology is the broken windows theory. The basic formulation of this theory states that visible signs of crime, such as graffiti, broken windows, and public drinking, builds an urban environment that encourages further crime and disorder. So based on this theory, we used a lexicon of crime, which is a vocabulary it's a set of words that people use when they're talking about their fear of crime, when they're in their like informal language. So we looked at the frequency that people talk about the fear of crime in the tweets when they're talking about a neighborhood. Sociologists also studied that casual and superficial interactions among residents of a neighborhood causes public familiarity and trust, and as a result, expectation of intervene if someone is in trouble. But an important factor in understanding the interaction between residents is understanding the type of activities that they conduct in a city, which affects their chances of public contact. So as a proxy for different types of activity that users conduct in a city, we use topic modeling and specifically LDA model to identify the topic vectors as proxies for different types of activities. We also represented the content of the tweets using the doc2vec embedding. Another feature we used was the public mood of the neighborhoods. We used several sentiment analysis methods to measure the sentiment distribution in the tweets that are mentioning a venue located in the neighborhood. We also compute two pairwise features. These features are computed for a pair of neighborhoods. We wanted to know, we hypothesized that neighborhoods that are usually close to each other are more similar in terms of collective efficacy. So we used spatial distance as an additional feature. We also assume that neighborhoods that have similar visitors are similar in terms of collective efficacy. So we also measured the Jacquard similarity of users that tweet about two different neighborhoods, A and B. So we extract all of these different features from tweets associated with a pair of neighborhoods and concatenate all of these features to get a single feature vector to characterize a pair of neighborhoods. This will be the input to the local ranker, which is our pairwise ranking classifier. In order to get the global rank of the neighborhoods, we aggregate the pairwise ranks, and this will be the global rank. We tried different classifiers for our local ranking classification task, including support vector machine, random forest, and multi-layer perceptron. The type of ranking that we do is actually a partial or partial ordering or a weak ordering, which means that two different neighborhoods can share a rank and are essentially tied. So we don't want to penalize the model when the model mistakes them or swaps them in the ordering, because they're essentially considered same. So in order to evaluate the similarity of two different rankings, which here for us would be the ground truth ranking of collective efficacy that we get from the survey
Moniba,
studies.
you have 5 minutes more.
Okay. And the ranking that we get from our model, we measure the Kendall ranking correlation coefficient, which is the dot product of the score matrix that we compute for each of these rankings. The Kendall ranking correlation would be 1 for two identical rankings. So we, in this experiment, we looked at top 40% of neighborhoods that were highly tweeted, which includes 157 neighborhoods in Columbus, Ohio. And we used the 90% of earlier tweets for training our model, and the 10% of the later tweets were used for testing. So in this figure, the x-axis is the tie threshold. Tie threshold is the value we use to define how we consider two neighborhoods as tied or having same ranking. So when the ground truth collective efficacy value for a pair of neighborhoods is less than this tie threshold we define, they're considered interchangeable ranking. For a tie threshold of 0, it means that the model has to rank every pair of neighborhoods and no mistake is tolerated. And the y-axis is the Kendall ranking correlation that I defined in the previous slide. We compare the performance of our model with a few baselines that we built. These baselines are essentially different orderings of neighborhoods based on different criteria. For example, the number of venues mentioned in their tweets, the population, the number of tweets, or the number of users that tweet about these neighborhoods. And as I mentioned, we also tried different our model with using different classifiers. As it can be seen in this figure, our model, no matter what classifier we use, outperforms the baselines significantly, and random forest does better than other classifiers. We did additional analysis to understand what linguistics features are better predictors of collective efficacy. It turned out that frequency of crime lexicon is not as good predictor as other feature combinations. And we also observed that if we have more tweets for neighborhoods, we are able to predict the collective efficacy rank more accurately. To conclude, we proposed a cost-effective mechanism to access collective efficacy of neighborhoods. The ranking generated by our model in some settings is more than 77% correlated with the ground truth ranking that we get from the survey studies. And obviously, there is no cost in building this model because we are only using tutor data. This model can be used as an early warning mechanisms for regulators and policymakers to monitor the transformations of neighborhoods and prioritize resources. In the future, we are planning to leverage data from other data sources, and also we are trying to use. We are planning to use different sort of information, such as EcoNet of users or other linguistics features to distinguish local users from the visitors and weigh what they say about their neighborhoods differently. I would be happy to answer any questions, or if you have any comments or want to discuss any of our work.
Thank you so much, Moniba. It was so interesting, your talk. There is a question here, if you want to answer it, and then I will come up with another question.
I'm not actually seeing the question.
No? Okay, I will read it. Does the length of the tweets in terms of text length affect your confidence for having Twitter as a monitoring tool?
Length of the tweets. Indirectly, yes, because we are extracting different features from it, like, for example, sentiment or frequency of crime lexicon. So basically, if most of sentiment analysis tools are working based on a lexicon, so if none of those sentiment words occur in the tweet, or if none of those crime words occur in the tweet, obviously we are not able to extract much information from it. Length of the tweets indirectly affects some of the features we extract. So the answer would be yes.
Okay, thank you so much. The question was made by Ronaldo Meneses. And I have a question based on the network that you use for doing your ground truth and the pairwise. If you give this information and this tracking to policymakers and they will intervene, do you consider that like analyzing the topology of that network will help your model in some way? Like if will be like a pairwise improvement in different networks that are not directly intervened.
So are you asking if using like topology of networks will improve the model? Are you asking that?
Yeah, like if they use your model for intervene and the neighborhood, like if the pairwise would be affected in the future, like an influence of neighbors.
So actually, if you're asking about like the direct application of this, so we are expecting this model to be just an early warning mechanism, and also like the only topological feature we have used so far was the Jakarta similarity of users who tweet about the neighborhood. So I expect other topological features would also be interesting to look at, but I haven't tried many more. And does that answer your question?
Yes. Okay. Thank you so much. Okay, I think, let me check in YouTube. I think we don't have more questions. Thank you so much, Moniba. If someone wants to reach here with more questions, can add to some for later on in YouTube. And okay, so please, Moniba, stop to share your screen, and we will start to share the screen of the next presenter. Please, Firas, if you can share your screen.
Yes, give me a moment. Let me see. Okay. Can you guys see it now?
Yes.
Okay, shall I start or?
Let me. We are good in time, so maybe we can wait 1 minute from people.
Okay, sure.
If someone wants to join the live, and I'll present you. Okay. Our next speaker is Firas Aswad, and he will present about communities of human migration in social media and experiment in social sensing. You have 15 minutes for the presentation. Please post your questions in Zoom to those that are in the meeting, and for guests, please in the YouTube broadcast. I will come to you when there are just 5 minutes left, and then 1 minute. You can start.
Thank you, Anna, for that. Appreciate. So my name is Firas Aswad, and today I'm presenting our teamwork with a paper titled "Communities and Human Migration in Social Media: An Experiment of in Social Sensing." And this work done by me and Dr. Hamoudat, Dr. Bero, and Dr. Menezes. So as Patrick Mining explained migration as one of those human patterns that can be seen from the beginning to the human experience to the present. First work done in human migration has been presented by Ravenstein in 1885 in his work of the law of migration. And at that time, he found very interesting points, such as females are more migrating than men in Scott towns. Later on, we have Stover, the first one who suggested a framework of human migration based on the number of intervening opportunity. I'm not going to explain those. It's just like a, let's say, a background in order if you want to more details, we can see it in the paper and the references. So why we are interested in studying human migration, we saw last decade, or at least recently in those years, many of immigrants, a huge amount of people from crisis area that has war or live in economy disaster start to move from areas to areas, and more precisely or specifically from Middle East, especially when Arab Spring started in 2012. We saw like many people from Syria, Iraq, and other areas start to move toward Europe through Turkey. And we all remember, I think, this photo for a 3-year-old Syrian boy when he drowned in Mediterranean Sea in 2015. This is one of the reasons that motivate us to do such an work in human migration. And if we talk about the other side, which is the official side, UN data. UN data, usually they provide their data about human migration every like 5 years, and there are a couple in between, such as 2 years and so on. Here you're looking to statistic done for bicontinental, such as Asia, Europe, and those numbers and in millions. So you see that in Asia, they were like in 2017, 80 million migrants from this part of the world, while in 2000, they were only 49. Another side, you will see like the top 10 host countries who receiving those migrants from all over the world. In United States, let me see if I can take this video down. Okay. In United States, you can see in 2017, there were 50, while in 2000, there were only 35 millions. So we continue with about the 10 bilateral migration. All this still like data comes from the United Nations official website. And as you can see in 2010, the first two countries that were like having those phenomena, the migration, it was from Mexico to United States, and in 2017 or 2010 to 17 from Syria to Turkey. So as you can see now, 2017, Mexico no longer, it's showing, as we hear in the news, that they are always having, let's say, illegal immigrant. In fact, nowadays we see that most of Mexican, they return back to their home country. So why migration again? So migration it has a big impact on the countries. For instance, on economy, it changed demographic landscape. It has effect on political stability. Usually, a tradition immigration data that usually comes from the United Nations, it's not enough because it's expensive and not enough in terms of granularity. While in social sensing, the social media information can be effective way to assess migration data. Decision can be support for policymakers. Immigrants are deeply connected to their origin home countries, and they form communities spatially segregated. Our objective in this work to propose a method to identify immigration communities and compare if communities in social media reflect the data from official census, such as the United Nations. An essential part of our work is to explain our methodology. So as I have mentioned before, so we use two types of data. One comes from United Nations official website, the other one from the Twitter that we collected by ourselves. And this chart shows the methodology that we followed in order to have our data filtered, then analyzed, then having the results. As you can see, we have a Twitter, we rely on keywords, language, and we collect data. We done pre-processing for the data in order to filter this huge information, let's say, in order to have, in the end, our analysis. I will go a little bit in details on this because it's very essential, as I mentioned. So we use the Twitter, and of course, you are all familiar with the Twitter API. This is the way that we collect our data from 2017, 18. And we have keywords. We use keywords in order to track our data. So the Twitters, the tweets that we collected, it has to have always keywords related to migration, such as refugee, immigrants, migration. This is how we can tell that this tweet is related to something about this phenomenon. Of course, in order to make our word broader, we used different language instead of only relying on English. And we have those 8 languages: English, Japanese, Spanish, Malay, Portuguese, Arab, French, and Turkish. Why those 8 languages? Because we have a study done by MIT in 2013 showing that those 8 languages are the most spoken languages in Twitter at that time, let's say, at least. So we have the Twitter's API look like this. We target the text of the tweet, the one that you see in orange color. So we extract that text from the tweet. Then we start to filter it by the country names and so on. This is just like a distribution of the tweets that in our data, and this is only small amount of data has GUI before it's banned. And the total number of tweets that we have collected so far in that time, it was 81 million tweets. And for what you're seeing at those points, it's only like around 64,000 geolocated tweets. In order to proceed with having data clean, we delete all tweets that has no text. Of course, we remove the tweet bot. We unify all the language into English only. As I mentioned, we have 8 languages, so we translate all these, what we extracted to only English, and then we filtered and analyze those data. And of course, delete the tweet if it has only one name of the country, because our network relies on 2 names of the countries in a single tweet. It's extracting country. So imagine if we have like a tweet, as you're seeing in your right side. So in the tweet, if it's mentioning like Syria, Canada, we take those 2 countries and link them. And the way that we linked, we use the link between countries using the concurrence of the country names in the single tweet. Of course, if we have more than 2 or 3 countries mentioned in the single tweet, we link with each other as click. the outcome of that network will be undirected network. So for instance, now we have this tweet, the United States has been, and so on. As you can see, we have 3 countries mentioned here, United States, Syria, and the United States, Somali, and Syria, Somali. This is the way that we connect them as a click. And we proceed that until we have the network be implemented using complex network tools. This the outcome of that network. I'm showing here only the few edges, the one that above 10, and this is for the Twitter dataset network. For the United Nations network, we have we rely on accumulative data of migration between 2015 and 17. Of course, we decremented the one 2017 from 15 in order to have a fair comparison with the Twitter dataset. The outcome of the outcome of this network is directed, and then we had an issue of having the data from directed to undirected. So we used 3 methodology to see which one is works or work better for the comparison, and we had choosing addition one. So same way that we did for the Twitter, we built our network and we had our network, as you can see. So in the end, this is the way that we end up with having our networks. Then we done some analysis in order to see if our data behave the same as the one that comes from the official sites. So we done the network degree distribution, which means here for our work, the diversity of migrants. And as you can see, by using the likelihood ratio fit model, we end up having a log normal distribution for both data set. Same done for the weighted degree distribution. And we have, you use the same likelihood ratio fitting model. When it comes to the community detection, we use, which is the main subject, we use the Lavin community detection algorithm to detect the communities. And we had 9 communities for both data sets. And we saw that some countries are geographically close in the same community, while they are sparse in other communities. In order to measure how well those communities are matching between Twitter and UN, we use the Jakarta similarity coefficient in order to see that match. Of course, if we have Jakarta similarity 1, that means the communities are identical. If it's 0, it means completely different. To do that, we had to measure the pairs of each communities inside with others. Like we take the Jakarta max for Twitter and United Nations. We took every max pair, then we delete them from the dataset and so on, in order to have max pairs of those nodes. Then we take the average in order to get the average Jakarta similarity, and it was 0.23. As you can see, it's not that much, but as I mentioned earlier, we have many of countries that have a good sign of similarity, especially in Africa and so on. You're looking at a heat map showing those communities, the 9 communities from Twitter and UN. And as you can see that we have communities such as community 7 from UN with community 6 from Twitter. They have almost like 0.44 match. And also for community 5 and community 2. Using that heat map, you can see that there are a couple of the countries that have good match, fair enough match between the United Nations data and with the Twitter, while for the rest is not that, let's say, good match. We done like a Venn diagram in order to just show, to visualize this match. As you can see here, we have Jakarta similarity for those countries, and we have 11 element here share. I mean, those 11, it's like 11 country between those 2 data sets, between United Nations and Twitter. And these are the 9 communities. As a conclusion, we saw the difference of Jakarta score among the community and the result between the 2 data sets, showing us that the public has a mismatch view of regularity, but slightly correct when it comes to some of the countries. in the end, people perception about immigration on social media doesn't reflect well the reality reported by United Nations statistic data. And that's it. Thank you. Please, if you have any question, let me know.
Thank you so much for
try to.
I have 2 questions. Sima, if you want to tell your question to Firas.
Yeah, actually I can see those questions right now. Let me see. Between the number of migration of.
Okay.
Yeah, what is the reason for significant difference between the number of migration in Asia and Africa? Is it because of data recorded? Actually, this might be the reason, but we have to remember that even when we talk about Asia and Africa, there are a couple of countries inside those continents that they don't have an accurate data set for United Nations. They don't have accurate data set. The way that they have the data set, if they got it from the official governments, that's fine, organization. Otherwise, they built like a small model and based on the population, the region, and they came up with the number of immigrants in that country. I hope this answer your question, Sima.
Okay.
And for what
Hugo has a question.
Okay, so the second, do you think that the mismatch of country comes from the lack of data on Twitter? This might be the reason, but also it's kind of like tricky because we did, so far we still looking for the data. I mean, till now we have data from 2016. Even right now we're collecting those data from Twitter. So we're gonna check like more data set and see more in different, let's say, situation, because as you know that immigration usually comes with big events that happening. For instance, like I said, in spring 2012, it was a huge event that happened in Middle East that made the migration increase, while some other years they had some other issues. So maybe the lack of data of Twitter also affected by the media and the news, or the news crisis. I hope that answers your question, Mariana. Any other question? I think
yeah.
Yes.
Hi, Firas. Thank you. Very, very nice presentation. My question is regarding a potential time delay between the actual migration flows and when these flows would appear on Twitter. Did you consider something like comparing like with different years for the Twitter data and the United Nations data? Because I'm thinking that a change in the migratory flow right now would reflect since it takes some time for the people to settle down in their new countries, and until they feel comfortable about having back their social lives and everything, it could potentially take some time for it to appear on Twitter. So do you consider comparing different years of Twitter with the United Nations migration data?
Yes, actually, this is a good question. Thank you for that, Hugo. We did like couple work on Twitter data in different time of year. Let's say I started in 2016. We done something with refugee precisely instead of like migration, and we did now the one that you're seeing in 2017-18. We have data also till 2020, but so far all we have using in those data, it's something about the text, which means that what you're seeing from those tweets, it's about people who are talking about migration. It's not maybe the actual people who are doing this refugee or migrating from area to area. In order to proceed with that concept, we have to consider maybe the geolocation. And since nowadays it's been banned by Twitter API, I'm using now different, let's say, technique from Twitter, which relies on the place of the Twitter itself. I'm planning to check if I can determine how many tweets comes from United States, and if this tweet has been tweeted somewhere else. I mean, the same person has already like an old tweet, and compare that as a link, let's say, moving from area to other area in order to see if there is a good framework to model, which is our optimal goal, to model this phenomena. It's not, I understand it's like live data. It's very important, and we can do that, but still the lack of having the geolocation for the tweets, this is one of the obstacles that we were facing before. So imagine if from 81 million tweet, we had only about 64,000, which is like less than maybe 8% of the tweets.
Okay, Firas, thank you so much again for your presentation.
Thank you.
I will ask you please to stop to share your screen, and we will go with Harith Hamoudat for her presentation. Harith,
hello, yes, you hear me?
Hello, yeah, perfect. Can you please share your screen? Harith?
Hello, yeah, just I'm trying.
Oh, okay, thank you so much.
Yeah.
Can you, is your presentation right now, or?
Yeah, it's just wait.
Harith, it does appear that your presentation is frozen, so you need to perhaps stop sharing and sharing again, please.
Okay, we can see your screen.
That's fine.
Okay, Harith.
My presentation?
Yeah, I will. You have 15 minutes. I will count, and I will come back to you when we have 5 minutes more and 1 minute.
Okay.
Please ask your questions as in the other presentations. Thank you so much.
Thank you so much. Hello, everyone. Thanks for attendance in this amazing conference. I would like to thank the chair of this session and the organizers for this conference. My name is Harith Hamoudat. I'm from Northern Technical University in Iraq. I will present a paper titled A Longitudinal Analysis of Vocabulary Changes in Social Media. The English language vocabulary has changed over the last millennium, but this change is quite slow and hard to notice from year to year. Compared with how things happened in the past, current changes happen faster than we expected because of the new technologies such as the television, radio, and overall world globalization. And recently, the internet has played an essential role in accelerating this process because of the use of social media and texting. Thousands of studies have been done in the field of languages in general and vocabulary in specifically. After 2000, the availability of the data was increased during the digitalized method and electronic books, in addition to the data of social media. Also, the development of statistics methods helps the scientists to do their studies in different fields of languages with more accuracy. For example, this study for Michael and his group, they used a corpus of more than 5 million books, about 4% of all books ever printed, for a quantitative investigation of cultural and linguistic phenomena. This data is for the period of 1900 to 2000, and they found that the vocabulary increased from around 500,000 in 1900 to more than 1 million in 2000, with an increasing ratio over 70% during the past 50 years. And most recently, the studies of language development start to use the data extracted from social media, such as this study of Isabella and her team. They examine the mobility of languages derived from geolocated tweets. They investigate a temporal and spatial evaluation of language using techniques such as the density-based clustering and self-organization map to detect real-world events and tourism trends. In this work, we studied and analyzed the size of vocabulary in social media to understand the growth of vocabulary and its relation with socio-economic factors. Also, we tried to predict the future of text in social media. To contrast vocabulary level with socio-economic factor, we used an educational attainment data set that's from US Census of American Community Survey for the time between 2010 to 2015. We chose the population of 25 years old and over, which is the biggest population in the Twitter in general. And we picked the percentage of high school graduation on higher for the people, or for the Twitter's people. This data set has a statistic as different resolutions, such as state, city, county, and zip code levels. And here's the map for the Twitter data set that we compare it with the educational attainment, which is one of the most popular microblogging platform nowadays. We used a large data set, contains about 569 million tweets, geolocalized tweets, belong to 17 million users. Those cities are located in 32 countries for the period of time, 5 years as well, from 2010 to 2015, which is the same date of the educational attainment data set that we choose. After that, we extract the cities from this 58 city. We extract only 14 cities belong to United States, because the data of educational attainment is just available for the United States, so we can compare the result between the two data sets. We did a lot of pre-processing steps for this dataset, for the Twitter dataset. We filtered out the incomplete tweets, we filtered out the duplicate, removed the users who appear to be moving in the city faster than, faster than the airplane. So we remove boots, and we remove the user who have more than 1 tweet in a second. Also, we extract the tweets that fell exactly inside the border of the cities, because there are some cities like here, Philadelphia and New York, for example, they shared some tweets. So because since the data was collected in bounding shape, so it's not important to reflect the real borders of the region. So we extract the exact tweets inside the borders. Here is an example for the exact borders for the city. For example, On the left is Chicago and Houston cities. We use just the tweets that fell inside these borders. We calculate the ratio of distinct word or the unique word, vocabulary word of the total, the ratio between the distinct word to the total words in all the regions. But because of the difference between the regions in number of tweets, some regions have just several thousand tweets and others has millions of tweets. So we need to normalize the data, and we regulate this equation to normalize the data. This equation is VR of S equal 1 divided by S summation K equal 1 to S U of K divided by N of S. VR is the average proportion of value, the average proportion value of the number of distinct word, the unique word UK, and the total number of word is NS, and the S is the number of samples used to calculate this ratio. And in order to find the size and the number of samples, we use the beta value extracted from Heap's law, which is one of the famous law in the field of languages. Heap's law represents the vocabulary growth for a certain language. VR of n equal kn to power beta. VR of n is the number of vocabulary word in the text of size n. K and beta are free parameters determined experimentally. We use the beta value from this equation to find the size and the number of samples in each cities. And here's the calculation for the Heap's law for all the 14 cities under this test with two parameters, K and beta for both. To find the number of samples that we use it in our calculation, we test a different number of samples from 1 to 10 and calculate the variance, and we found that the variance between 5 and 6 can enough to represent the data. This is belongs to the number of samples, while the size of the sample we use the same parameter, which is beta value, and we test different sample size from 1,000 to 10,000 tweets to see which number of tweets can represent the whole data. And we use the need detection, and we found that 4,000 it's enough to represent the data in our work or in our case. After we calculate the vocabulary ratio between the among all the cities that we have it, we calculate the correlation between the educational attainment from American Community Survey and the vocabulary ratio that we calculated from the above equation. We start with all cities together, and we found that the correlation is about 0.66, which is positive correlation, but it's not that high with a significant p-value. Then we split the group of the cities into two groups, and also calculate the correlation between the educational attainment and the vocabulary ratio, and we see that the correlation is increased when we split into two groups. Then we try to calculate the calculation also between the same two data sets with the counties inside each city. And we see that the correlation is higher, which means the small resolution for the data test, it's better correlation. When we increase the distance between the cities or between the region under the test, the correlation be lower and lower.
Harit, you have 5 minutes more.
Okay. So from the educational attainment data set, we noticed that the level of education increased over time, year by year. We split our data set from 2010 to 2015, and we see that the level of education over time increased year after year. So So we already proved that the vocabulary ratio is positively correlated with level of education. So we expected to see that the level of vocabulary increased year after year as well in the same period of time. But we noticed that the vocabulary ratio increased in 2010 to 2011 until 2012, all of them increased. But after 2012, there's a start to drop in the number of distinct words or the vocabulary ratio in the social media or in Twitter specifically. And then after 2014, almost stable. When we tried to see the reason behind this phenomena, we found that the adoption of emojis in the last few years affect the vocabulary size in social media. So this is one reason, maybe among different other reasons still hidden for us, that affect the level of vocabulary. The users of Twitter start using the emoji to describe their status instead of words, which leads to use fewer words than normal. As you can see here from this figure, in 2010 and 2011, almost there's a zero emoji or point, very small ratio. But starting from 2012, the number of emojis start to increase until 2015, which is affect the ratio of vocabulary, the number of vocabulary ratio. So we calculate the correlation between the vocabulary ratio and the emoji ratio for all the 14 cities, and we see for all of them there's a strong negative correlation between all the cities. We use just from 2012 to 2015, which is 4 years, because before that we don't have data for we don't have emoji, so we just correlate 2012 to 2015, and for all the cities is a negative, strongly negative correlation, as you can see here. So our finding from this work, we found that the ability of vocabulary to reveal the educational attainment of population for a specific region. Also, the social media text can be treated as a regular text because of the diversity of subjects, which leads to the variety of vocabulary. Our method can be served as a simple measure of educational attainment for region where official data may not be available, which is like a sensor. And also the using of emoji start to be noticed after 2012 and affect the number of vocabulary in social media. My future work is the relation between the vocabulary size and other factors such as the income level and the city size, several languages for different period of study, the effect of the time on level of vocabulary, and we try to classify the languages according to a temporal effect of using emoji on different languages. And I will give a big thanks for my collaborators, PhD candidate Firas Aswad, Dr. Ilardo Romero, and Prof. Ronaldo Benitez. Thank you.
Thank you so much, Hadith. That was a very nice talk. We have a question in YouTube. I will read to you. And so Firas Aswad is asking on YouTube, how did you extract the tweets exactly for the states which share borders?
Well, we extract the map first. We extract the map, QGIS. Using the QGIS, we extract the border of each city. Then our dataset is geolocalized datasets. So we drop the tweets inside each border exactly.
Okay, perfect. We have, if Firas that answered your question, he says thank you. We have a question from Professor Ronaldo Benitez that I'll ask.
So, thank you, Anna. So, Harith, it's a little. So, thanks for the presentation. So, although I participated on the work, I actually have a question for you regarding the the link to emojis, right? So have you tried this with other languages, right? Because there may be cultural constructs in here in terms of how a particular culture use emojis and what time this was adopted, just to confirm whether this could actually indeed be a valid hypothesis. For instance, I mean, I don't know. So I guess we have a colleague, Maddie, who's an expert on the use of emojis in social media, but so he could probably answer this. But the idea is that could we see that the adoption was delayed in certain locations in terms of use of emoji, and would that be reflected? Have you tried with other languages like yours, for instance?
Yeah, actually not yet. I didn't try with other languages because I just extract the English language right now. But my data set has also other languages like Spanish, there's some Arabic, some Chinese. So I will try to see if the emoji is same behavior, and I already add this for my future work to see if the use of emoji can make a difference between the languages, or can we classify or detect the language from using the emoji for those. But right now I didn't test yet.
Okay, thank you.
Okay, thank you so much, Harith. We have another question from Hugo. I think that you are on mute.
Hi, Harith. My question you mentioned in your future works was about the possibility that these educational attainment being just a confounding factor with socioeconomic development of a region. So what are your thoughts on that? Do you think that the basic or the fundamental factor to affect the vocabulary size is indeed the socioeconomic development, or do you think it is beyond that, it's more at the educational level?
Yeah, Yoga, thank you for asking. Yeah, I believe that the number of words per person, it's strongly related with his level of education. So the main idea is to find the level of education for a group of people in a specific region and compare it with the region with the neighbor region. So we tried to, sometimes the statistic is not available for some regions, so we can approximate the level of education for some regions based on their vocabularies from Twitter dataset when the official statistic is not available. So I don't know if I answer you or not.
Okay,
so he's saying yes. It's because I don't think he can unmute himself. Okay.
Thank you, Harith.
Thank you very much.
I have a last question if we have time. We have 1 minute more. Have you related the content, or have you checked if the content of the tweet is related to the measures of the length of words and the number of emojis, like in some sort of topic detection?
It's not, no, it's a general data set. It's collected according to the geolocated, so all the tweets in those cities are collected in randomly without a specific topic.
Okay, Harith.
Thank you.
Thank you so much. Okay, thank you so much, Harith, for your presentation. It was so nice. I will ask you to stop to share your screen, please. And now I will ask to Alexander.
Here.
Hi, how are you? Can you please share your screen and we can start with your presentation?
It's okay?
Okay, thank you so much. You have 15 minutes. I will come back when there are 5 minutes left and 1 minute.
Okay. Hello, good morning, good afternoon, or good evening from wherever you are. My name is Alex Toledo, and today I will present the work Diversity Analysis Exposed Inspected Key Roles in Multiplex Crime Network, co-authored with Laura Carpi and the Albans Atman. This work was developed at the Federal Center of Technological Education of Minas Gerais in the partnership with the Military Police of Minas Gerais, Brazil. And 6 new approaches and answers to meet a growing demand of society to mitigate crime. And we present an innovative analysis of crime occurrence in the state of Minas Gerais, Brazil, collected from the Public Security Intelligence Database, from the point of view of statistical physics and the complex network. The objective of this work is to study a criminal network as a multiplex structure in which node corresponded to criminal individual, and the layers corresponded to different crimes. We use the concept of diversity in multiplex networks to identify individuals that are crucial for preventing the network functioning independently of their centrality values. By doing this analysis, we found that the node diversity analysis was able to reveal interesting new features, providing information to identify individuals with important roles in the network, not identified by traditional measures. This work was developed at the Federal Center of Thanks. We use the links of occurrence database, collect through observations of intelligence agents by the Military Police of Minas Gerais. This database contains 152,973 registrations of individuals related to different crimes, and it also contains information regarding situations in which individuals have been connected. The figure shows a criminal network contains 34,505 nodes and 46,239 links that were created if any of these connections exist in database. From the original data, we select a group composed by 92 individuals that were the target of intelligence operation. So, first, we use a more traditional approach, and we compute 3 centrality measures that are degrees centrality, between centrality, and page range measures that are commonly used in studies of criminal network. For the study, all elements are anonymized. Mean values of these 3 normalized centralities measured have been computed of and the individuals 80, 51, 40, 11, 47, 81, 19, 2, 44, and 90 have been identified as the more central in the classing order. And in sequence, a multiplex structure was constructed by considering the network of the different crimes as layers. The crimes considered are ideological falsehood, armed trafficking, kidnapping, weapon carrying, homicide, theft, and the drug trafficking. The figure represents the 232 edges in the layers multiplex. We use a diversity measure proposed for multiplex structures that is based on the distances between its elements, nodes, or layers. And distances are computed through a measure based in Janssen divergence and no distance distribution. I am not present the detail of this measure because of the limit time, but if you are interested, you can access to paper detail in the slide. So, as we said before, the diversity measure quantifies the variety of heterogeneity of the connective configuration of patterns that a set of elements, nodes, or layers possesses. Diversity was computed at two different levels: local diversity, which refers to the diversity of the connections of a node in various layers, and the global diversity, which refers to the diversity of relationships, partners in the system. High diversity value indicates a high number of different links configurations. A low diversity value indicates a low variety of links configuration and the presence of redundant links. So, in our first analysis, we found the individuals 80, 51, 48, and 11 as the more central ones in the classing order. The individuals with higher diversity value also in the classing order are 48, 8, 47, and 21. So individual 48 is the one that possesses a higher variety in connection patterns. That more than individual 8, that is more central with a high difference with the older nodes. As high diverse node mainly overlaps with central nodes, centrality, diversity, correlation study has been performed, find 0.46, indicating weak correlation. In the figure, red dots represent the diversity values of each node in the multiplex structure, and the blue dots represent the node centrality value considering the aggregate network. So why individual 48 is special? Because 30 more central nodes and participates in more types of crimes, possesses a high number of redundant links with node 18 individuals, the higher centrality value. Is the only individual that participates in the armed traffic network from the list of most central nodes.
Alex, you have 5 minutes more.
Okay, then we can confirm that the presence of individual 48 guarantees the well functioning of the multiplex crime network, having a more important role that individual 8 that possess in highest central value. Well, the conclusions we present in this article innovative approach to analyze criminal structures from the public security database via complex network analysis. By using the concept of diversity in the multiplex analysis, it was possible to identify nodes with main roles in the criminal network. We found that nodes with not so high centrality values, but high node diversity execute crucial roles in the network for the achievement of the effective functioning. With the proposed methods, we believe policy have gained an important tool to identify, visualize, and quantify criminal activity in real time, increasing the chance of a successful interruption of crime. We hope to apply this method to other databases and eventually integrate it with social data to evaluate possibly hidden connections between individuals and also hidden key actors.
Thank you so much, Alex.
Yes, thank you.
It was a very nice presentation. There is some questions. I will start with the first one that Sima is doing. Could you please explain more about your multiplex crime network? What was your assumptions for each layer and for the connections of intra-layers?
1 minute, I'm
okay.
problem here.
Yeah, for those that want to ask.
Oh, okay.
Okay. Okay. So I will.
My connection is bad today.
Okay.
Repeat, please.
Yeah, I will repeat.
Very bad.
Don't worry. Could you please explain more about your multiplex crime network? What was your assumptions for each layer and for the connections of intra-layers?
Okay.
Would you want to? Okay, share again. Okay.
This?
Yes, like what are connecting the nodes inside the same layer, the intra connections.
The 7 layers are the crimes all individuals, the multiplex network. I create 7 layers with 7 crimes: the ideological falsehood, arms trafficking, kidnapping, weapon carrying, homicide, theft, e drug trafficking. These crimes is relational with the elements or criminals my study. The network is more big, but I study 92 elements.
Okay. Thank you so much. I have 2 questions from YouTube. So Basim Mahmoud, he's asking, have you tried 2 other network measurements to compare other network measurements against the diversity? You considered that in your work?
Here, and the diversity mensuring and the first I analyze 3 measures: centrality measure, and the between measure, and the page rank.
Okay.
But it is not my objective. This diversity measuring in the script, the ascending diversity in multiplex networking in Laura Carpi, my co-authority, this quantify and the exposing this measuring with more details.
Okay, Alex.
But the important in the vast measuring, this one element, this is very important. The individual 48. These individuals is free today, but the individuals 80 no free is the prison last 5 or 7 years ago, but the element 48 is free today.
Okay. Okay, Alex, and thank you so much for your answers. Thank you so much to all the speakers in this session, to Moniba, Firas, Harith, and for you, Alex. It has been so nice presentations, and we will finish this session. And we will come back. We will have a break now of this session, and we will come back at 3:40 British summertime to start the 3rd session. Thank you so much for the audience and all the cheers. Thanks, everyone.